Hello YouTube Vintage Stereo Restorers. Hey, I want to talk about this Nikko TRM-50. Sometimes I get across what I want to talk about in one take. Not the case today. There's a lot to talk about with this one. First of all, how good it looks. Here we go. These two boards, which are the 1973 upgrades for the original module. So we're taking something that was an integrated circuit with a high failure rate and replacing it. So there's the original service bulletin, widely available. And there are a couple things about it, this particular installation, that weren't done according to the bulletin that were causing problems. One was this diode bridge. Well, there's one on the board. These two here, there's a varistor and a diode, thermistor, whatever you want to call it, and a diode. And why a triple diode bridge was put across that, I don't know. Wasn't needed. Anyway, it is a pretty simple circuit. This is the schematic they give you, 4-transistor circuit, which mimics, it's a very commonplace NPN, NPN, PNP, NPN driving the outputs. And I took out the tip 41s that were in there and put original 2SD154s. I thought, well, either that or 2SD91s would work, but these are actually, they test well, and they came out of a Lafayette unit that was badly damaged. Came, via eBay and was smashed up. Anyway, kept those parts. Interesting thing about this is there are no mica insulators. Because each heatsink is on its own, you don't need them. You just need a little thermal grease. And then on the boards themselves, I got rid of the... Oh. Here, pour them out. Some of those. The C815s. And... where's the other? Oh, yeah. That one, whatever that... what was that one? A 2SC1335. They were a bit noisy. There's a lot of residual noise with the volume control down being generated on that board. The other thing is the way they were in, they were actually sitting on top of the heat sinks with a little bit of duct tape underneath and some kind of cement, looked like model airplane cement, holding them down. The thermistor and the diode should be near or on the heat sink. Just for it to work, it creates a feedback loop, keeps the bias in check. Since I put these parts in, I've tested it out. Center voltage is 24.4, and then the full rail voltage is 49.9. That's perfect. There will be no crossover distortion. The bias is about 11 millivolts, and it is adjustable. The controls are kind of hard to get at. So I wanted to secure these down, very secure. And I will actually put the transistor substitutions I used in this circuit on this video. It'll just be in the information, though, for those metal ones. And I ran this for about 3/4 of an hour this morning. Very cool running. Sounds much better. Runs speakers no problem. But I want to make sure these boards are actually fastened down well. Right now I have a wire tie holding each one with, that sticky foam that you get. You buy it in an art pack. I use that quite a bit for changing light seals on cameras. And in certain places, like when I'm repacking capacitors and stuff, I will actually wrap it up inside. It makes a great insulator. In this case, this is where these boards are supposed to be. I put a piece of that foam, stuck it on to that side of the heatsink so that the, you can see this here, so that where you've soldered, all the metal on the back won't short out. And it's fairly secure with those. I don't like things that aren't secure, because the way it was before, it could have actually This one here, it was touching bare metal right there. You could easily blow transistors, and then you got to take it apart and do it all over again. So my plan is, I've got the wire wraps on there. I don't think they look that good, but what I'm going to do is put a little glue on the edge. I was initially going to drill these boards, use plastic standoffs, and drill into the heatsink. And then I started to drill one of these boards. And I'm talking about 5 seconds of drilling, and the way the board was drilling and the way it was flaking off the phenolic resin, I knew when the drill bit went through it was going to crack the board. So I decided I'm not going to drill that one, I'm going to fasten it like this. So right there, just a little bead of hot glue. And it has to be in an obvious place. So if you ever have to take this apart, you're like, oh, it's hot glue there, it's hot glue there. Well, what do? You just kind of take an X-Acto knife, break it off. With these new transistors, and I checked every resistor and recapped the board, it should be good for quite a while. So right here, I'm just going to put a little like that. Put a little 3 much on there. That happens. There we go. You gotta be careful of that hot glue. It is hot stuff. So what we'll do is we'll let this end dry, and then I'll flip it over and do the other end. And then cut the wire ties off. And then that'll just look like they belong there. The next thing I gotta do, I'm not sure how to handle this. I did do one a few years ago, and I have some pictures of it. There's the 2 ICs here. Tone controls work, volume and balance works fine. Controls aren't crackling or anything. But to actually spray the controls, you gotta pull the board out, which is a bit of a pain. So I might as well do some work. It looks like it's been completely recapped with good caps. But what I think I'm going to do is I will make up a substitute for that, because the one thing I'm noticing is it has that ceramic capacitor sound. I don't know if you know what I mean. The highs are just a little brittle, so replace the ceramics that are in the audio path. I want to make this sound nice, and then we'll get to this pesky left channel phono. That'll be the third thing that I fix. Anyway, thanks for watching and listening. I'll keep you up to date.